Good morning, everyone. Here is Mr. Grenfell, Professor Grenfell, with another video for Math 12 Statistics at RCC. And here we are continuing in Chapter 3, Section 3, talking about measures of relative position. And I promised a little bit more detail on percentiles. So here, allow me to write the formula. So the percentile, or the percentile rank, is defined as the number of values below x. So x is some value in your data set, and you count the number of values that are below that. So you have to arrange them in numerical order in order to do this, similar to how we find the median. And then that's a whole number, so we add a half to it. So then we have a decimal value, and we divide that by the total number of values in our data set, and then
times 100. So yeah, I jotted this down so I could remember it as P equals C plus 0.5 divided by N, all times 100. So let's use this in order to do example 3-30. Here they're talking about the number of traffic violations. They say the number of traffic violations recorded by a police department for a 10-day period is shown. Find the percentile rank of 16. So they gave us the values, and the first thing that I did is I recopied them in numerical order from lowest up to highest, and then I decoded the instructions as find P of 16. So here P is going to be the percentile rank. We're not going to confuse that with a probability or a percentage, hopefully. All right, so we have to then find 16 in our data set. We have to count the number of values below it, right? So there are 1, 2, 3 values there. And then we'll use this formula. So P is equal to C plus 0.5 divided by N times 100. So this becomes, plug in 3 and place C plus 0.5 divided by 10. There's 10 values in the data set. And so this works out, I'll put in one more step, 3.5 divided by 10 times 100. And so this is the 35th percentile. Okay, so let's move on to example 3-31. And in this one, it says, using the data in example 3-30, find the percentile rank of 24. So I've written that down as find P of 24. So here, similarly, we'll find that value in our data set. We'll count the number of values that are below that number. So we have 3, 4, 5, 6, 7, 8 values below it. All right, so here P is going to be C plus 0.5 all divided by N times 100. So we're substituting in 8. Just do the quick mental math, 8.5 over 10 times 100. And here we can divide the top and the bottom by 10, and then scoot the decimal point 1. So this would be the 85th percentile. So just simply complete that computation. So in the previous 2 examples, we were given a value in the data set, a data value, and asked to find the corresponding percentile value or percentile rank. And now in these next 2, we're going to see an example of doing the opposite. We're going to find the data value that corresponds to a specific given percentile value. So the instructions for example 3-32, as you can kind of probably imagine, it says using the data in 3-30, in example 3-30. So here you can see I've recopied that data. Find the value corresponding to the 65th percentile. So that's why I've got find x for p equals 65. Or I could say find x corresponding to the 65th percentile and write it out in words like that. But I tried to break it down into, more concise language, and if you understand the formulas, then that's pretty much as compact as you can get. Here, the procedure, the formula, is C equals N times P divided by 100. And so here, C represents some kind of count. We're going to do a counting procedure. N is the total number of data values. P is the percentile ranking that we're given. And of course, 100 is just the number 100. So that is built into the formula. We always are dividing by 100. So here we do the computation first. We plug in 10 in place of n. So there's 10 values in the data set here. We're substituting in the whole number 65 in place of p. So since we are going to divide by 100, we'll just leave that as a whole number that is somewhere in between 1 and 100. And we obtain 6.5. And now the procedure aspect of it kicks in. So we did the formula, and now we're going to do the counting. This is going to bump up or round up to 7. If C is not a whole number, round it up to the next whole number, or increase it to the next whole number. So C is now 7. Using that increased value of C, we'll count over to that value in the data set that corresponds to that count of C. So we're going to count over 7. 1, 2, 3, 4, 5, 6, 7. And we obtain a value of 20. That is the 65th percentile. In the next problem, we're going to find the data value that corresponds to the 30th percentile. So I've written down find x for p equals 30. So we begin the same way. We're going to write down the formula from memory, of course. We're substituting in the information that they give us. So we have 10 data values. We want to find the 30th percentile, and then we always divide by 100. The formula is always that. And so here, the value for C that we obtain is 3. Unlike what we do when we are finding class width, if it is a whole number, we'll keep it at that, and then we'll just do a different procedure. So the procedure here is to take the average of the C and the C plus 1th value. So that is horrible to say. So this is a mashup of math notation and English, and it's, of course, horrible. What this entails is just, well, in this case, C is equal to 3. C plus 1 would be 4. So we're looking at the 3rd and the 4th value, and we're going to split the difference, or average those. Take the mean, in other words, of 2 numbers. So we say x is equal to 15 plus 16, then divide by 2, and that gives us 15.5 as 30th percentile. So the value, the data value, x equals 15.5, corresponds to the 30th percentile. All right, next, let's talk about quartiles. All right, we're only at the 10-minute mark, thereabouts, so we'll be able to speak about what quartiles are and do an example with them, and keep this video still short but sweet. Now, quartiles, by definition, are the 3 boundary values that subdivide our data into 4 equal sets. So in order to find the quartiles procedurally, we will first find the median that divides the data into two equal sets. Then we will find the median of each of those halves of the data set. We'll split the data into the lower half and the upper half, and we'll find the halfway point of each of those, and that will give us four equal in size, equal groups of data. So example 3-34 says, using data in exercise 3-30, find Q subscript 1, Q subscript 2, and Q subscript 3. So these are the three quartiles. Okay, the first thing to do is actually find Q subscript 2, and we'll start by finding the median, all right? And here, the median, how do we do that? Remember, here we have an even number in our data set, so we're going to take the average of the middle two values, and therefore Q subscript 2 is going to be the median, is 18.5. So we've split the data into two equal halves. So the second quarter, that's halfway through. Next, we will focus our attention on the lower half of the data set and find its median. So here we have split 10 values in half. That gives us 5 in this lower half. And so the median is one single value from the data set itself. That is 15. Likewise, we will then examine the upper half of the data set. Go ahead and find its median. There it is, right there. And so that is the third quartile. And often they will ask us to give the what they call the 5-number summary. And so here that is just including the minimum value, the lowest value in the data set, and then the first quartile, the median, which is Q subscript 2, and then after that, the third quartile, and then finally, the maximum value, or the largest value in the data set. So that is what is known as the 5-number summary. Next, let us move on to the next example, 3-35, and we'll discuss the interquartile range. The interquartile range, by definition, is the third quartile minus the first quartile. So that would be Q subscript 3 minus Q subscript 1. And in example 3-35, they say find the interquartile range of the data set in example 3-30. All right, so that gives us, or simply plugging in what we found in the previous problem, 22 for Q3 minus 15 for Q1, and that would be 7. What we usually do with the interquartile range is we use that to test for outlier values. And so in this case, IQR times 1.5 gets us 10.5. In order to be an outlier, a data value would have to be 10.5 away from Q subscript 1 or 10.5 away from Q subscript 3. And so you can see that this data set has no outliers. Excellent. We've managed to wrap this video up in under 15 minutes. I'll see you in the next video for Chapter 3, Section 4 on EDA, Exploratory Data Analysis. All right, stay tuned. See you next time.